we are going to see about the root locus technique. So root locus method. So objectives of this class is to understand the definition of root locus and to learn the steps to sketch a root locus. So first of all, root locus, it is used to determine the stability of the poles. So here it is the closed loop system response depending upon the location of closed loop poles. So based upon the location, we are going to determine the stability of the closed loop system. So initially the definition of root locus is that the path taken by the root of characteristic equation when open loop gain k is varied from 0 to infinity is called as a root locus. So it is an analytical method which shows graphically the location of poles of the closed loop transfer function as a function of design parameter of the open loop transfer function. So it is used to calculate the accurate stability of the closed loop system, and also it is a powerful method of analysis and design for stability and transient response. So root locus gives a graphical representation of a system stability. So we can clearly see the ranges of stability, instability, and conditions that cause a system to break into oscillation. So let us move on to the steps that are used in calculating the root locus. So there are 5 basic rules to sketch the root locus using minimal calculation. So first step is to locate the poles and the zeros. So here the poles are marked by X and the zeros are marked by O. So number of root locus branches is equal to the number of poles of open loop transfer function. And the origin of the root locus is at pole and starts at pole and ends at 0 or at infinity. So this is step 1, and step 2 is locating the root locus on real axis. So to decide the part of root locus on real axis, take a test point on real axis. If the total number of poles and zeros on the real axis to the right of this test point is odd, then the test point lies on the root locus. If it is even, then the test point does not lie on the root locus. And the next step is to calculate the angle of asymptotes. So the formula for angle of asymptotes is given as plus or minus 180 degree into 2q plus 1 divided by p minus z, whereas q varies from 0, 1, 2 up to p minus z minus 1. P is the number of poles and z is the number of zeros. Next is the calculation of centroid. So centroid is the meeting point of the asymptote with real axis. So the formula for calculating the centroid is sum of poles minus sum of zeros divided by number of poles minus number of zeros. So after calculating the centroid, we have to calculate the breakaway or break-in points. So at the breakaway point, the root locus breaks from the real axis to enter into the complex plane at break-in point. The root locus enters the real axis from the complex plane. So to find the breakaway point from an equation for K from the characteristic equation and differentiate the equation with respect to S, then find the roots of the equation dk by ds is equal to 0. The roots are breakaway or break-in point provided the gain value K, it should be real and positive. So after calculating this point, the next step is to calculate the angle of departure and angle of arrival. So if there are any complex poles or complex zeros, this angle of departure or arrival comes into the graph. And the final step is to calculate the point of intersection of root locus with imaginary axis by substituting S is equal to j omega in the characteristic equation and then separating the real part and imaginary part and solving two equations for omega and k. The value of omega gives the point where the root locus crosses the imaginary axis, and the value of k gives the value of gain k at this crossing point. So based upon these steps, here is an example that is derived, and here the number of poles are 4 and number of zeros is 1. Therefore, the number of asymptotes will be n minus m, that is equal to 3. So here the centroid is calculated and angle of asymptotes are also calculated. And it is marked in the graph. Then breakaway or breaking point is calculated using the given formula, and the root locus is identified. And after finding out the intersection point, like it lies in between around minus 1.9 j plus or minus 1.9 j is the intersection point. The graph, that is the root locus, crosses over this intersection point. So in this way, the root locus plot is solved and the stability is verified.